Number 4, know how a crystal lattice forms for an ionic compound and how this relates to its physical properties. So crystal lattice is just the name we give to the structure that it forms. So it's the name of the structure ionic compounds form. Let's do it this way. We'll make it bullet points. It's a repeating pattern. So it's a repeating pattern of the, oops, I got 2 ofs there, of the positive and negative ions. So alternating, I should say it's a repeating and alternating of the positive and negative ions. So they line up every other one. So if you're a positive ion and there's negative ions on each side, front and back, top and bottom, you're surrounded by at least 6 other negative ions. You're not going to move very well. So it asks, how does this relate to its physical properties? Well, in order for something to boil or melt, the ions have to spread out or move around. So the fact that it's held in this tight pattern is why it's got a high melting point and boiling point. It's why the ions can't move and allow charge to go through it. But it's also why it's brittle. So properties of an ionic crystal lattice, if we talk about this, the rigid, tight structure is why crystals are hard with high melting and boiling points. Again, because the ions can't move easily. That's also why it's a poor conductor as a solid. Because the ions can't move. And it's why it's brittle. Because when you hit it with a hammer, now you don't have alternating positive and negatives. You have a bunch of positives by each other and a bunch of negatives. So I'm just going to say it's brittle when hit because the pattern gets messed up. And like charges repel or crack the crystal.